Good evening, everyone, and welcome to the fall meeting, the first fall meeting of the Gene Winter Northeast chapter of the Mass Archaeological Society. I'm Vic Massone, I'm the chapter chair. We're really excited that we were able to, through the help of the Peabody Music Institute, to bring back our lecture series while we can't meet in person. So we're not going to have a chapter meeting per se, just a lecture. For those of you who are not members of the Mass Archaeological Society or of the chapter, please consider joining. The chapter is a very modest $6 a year, and that helps us defray some of our costs and some donations that we make to institutions, our mothership and so on. And that's really about it. Our next chapter meeting is going to be on, I have to look at my calendar, October 20th, again, Tuesday evening at 7. Greg Watt is going to talk about Norse. He recently went to Iceland and learned a bit about Norse ironworking, and I believe that's going to be the main focus of his talk, but he's a really good expert on sort of Norse exploration towards the Northwest Atlantic. And that's what I've got to say. Oh, just as some ground rules, you will not be able to call in questions. You can use the chat feature, and at the end of the lecture, we will tackle the questions, and we do restrict them to the topic at hand. We don't want other questions. There's not going to be enough time to field everything for everyone. Thank you.
Okay. John? You have to unmute yourself.
Hello?
Okay.
Good. Welcome, everyone. Tonight's presentation, oh, that's, happy Halloween.
That's Elsa.
That's Elsa. Tonight's presentation will be by Dr. David Leslie. Dr. David Leslie is a senior archaeologist at Archaeological and Historical Services in Connecticut. He has over 15 years of geoarchaeological and environmental archaeological experience, and he's worked on archaeological projects all across the Northeast and also in Kenya and Europe. Dr. Leslie did talk to the chapter before when he presented on underwater archaeological research he undertook, looking at submerged ancient landscapes. And tonight he'll be talking about the oldest human occupation in Connecticut.
Okay, well, thank you, John, for that introduction. Let me try to share my screen and get the PowerPoint started here. Can everyone hear me? Is the audio working? Yes, okay. So, like John said, let me try to minimize this. I'm going to be talking today about Paleoindian occupations in central Connecticut along the Farmington River at the Brian D. Jones site. Let me try to hide this taskbar. I'm afraid you won't be able to see some stuff. Anyway, let's move on. So we'll be talking today about the Brian D. Jones Paleoindian site. This is a site that was discovered on the west bank of the Farmington River in Avon, Connecticut. So you can see here as I move the cursor, I don't have a laser pointer, won't work for this, so I'm going to be using the cursor throughout to sort of draw your attention to areas here. This is where the site was discovered. Here we are in Connecticut. This site, as I'll discuss, was named for the late state archaeologist in Connecticut, Brian Jones, due to his contributions in helping to discover the site and also helping us to excavate it before he passed away tragically with a fight with cancer last year. A little bit about the project background. The Paleoindian site discovered in January of 2019, as I said, on the Farmington River here in Avon, Connecticut. The site itself is buried about 1.5 meters, 5 feet below the current ground surface of the site, of the ground. You can see our project area here in green, and this is sort of what the project area looked for the bridge construction. This is a site that was discovered as part of cultural resource management or compliance work in association with the Connecticut Department of Transportation for a bridge replacement project here in Avon. The bridge site, discovered by Ken Fader and then later excavated by Fred Warner, was discovered in the 1980s. And you can see these red boxes here are where this middle woodland site was excavated in the 80s and 90s. So as part of this work in 2014, AHS with Brian Jones, before he was the state archaeologist, undertook what's called a phase 1 survey, where we excavated shovel test pits in this project area here. They undertook a phase 2 of the bridge site itself here. We didn't find any remnants of the bridge site at all. It looks like Fred got most of it in the late 90s when he excavated it. But what we did find, as you can see here on the left, are deeply buried alluvial or river deposited soils. So here we've got a 1 by 1 meter that's been excavated down, over 3 meters here in depth, where we did a telephone booth, sort of deep excavation sounding here in sort of a 50 by 50 centimeter square to discover that these soils go very deep, and we don't have the sort of common glacial soils at about a meter or so deep that you find throughout most of New England. In part of this work, Brian recommended that deeper investigations would be necessary before the bridge was built. So in the deeper areas where the soils were going to be disturbed through bridge construction, that area should be investigated with additional archaeological research. So we fast forward to 2019, when AHS once again undertook this work, where we monitored the removal of soil with a flat landscape blade, as you can see here, with this backhoe removing soil in 30 centimeter increments down to a depth of 1.5 meters to that surface below where we could no longer excavate with the original 2014 survey. At about 1.5 meters throughout this area, we found artifacts, as you can see here. To the left, we've got this large hornfels flake. We have a jasper channel flake here that refits, and a jasper large thinning flake here. The channel flake was, as you can imagine, a sort of dead giveaway, as well as the deep artifacts that we had something pretty old. The shovel test pits were excavated at 5 and then 2.5 meter intervals. And as I've already alluded to, we discovered a Paleoindian site. One of the other things that we did while we were performing the initial removal of soil was we did a ground penetrating radar survey on the original surface up here, where my cursor is, and then the stripped soil area down here. So this is me running the GPR machine. To orient you, the river is this direction, and to make it difficult, I guess, I really need to hide this taskbar. Just 1 second. I can't figure out how to hide it, so we'll have to deal with it. Anyway, there's a thing down here that says to the river is this direction. So the river in the GPR is this direction, and up here in the picture, it's this direction. It's not so clear to everybody who looks at this image down here, I know, but there are clear differences between the later period Holocene soils here and the Pleistocene sediments that preserve the archaeological site here with the red box. This, as you can see, diving down is actually Pleistocene sediments that preserve a levee or a sort of long ridge or terrace along the edge of the river here, next to the Farmington River, that protected this site. And this is another way of looking at that ground penetrating radar information. Here we're looking at a plan view at about 50 centimeters below the strip. So another 1.5 feet or so deep, about 6.5 feet deep. And what you see here is the edge of this Pleistocene landform. So the river would have been down here. These darker sediments here is that Holocene alluvial sediments. So we're actually looking at the edge of the landform here and then going this direction where the Paleoindians would have encamped. A little bit about the river geomorphology. As I said, the site is situated on a Pleistocene levee of the Farmington River. Here you can see the red dot where we are. This is the Farmington River coming this way, south. And then as you see, it flows north, which is quite odd for rivers in Connecticut to flow this far north. It's doing this because there's a glacial moraine here in Farmington. You can see, you should be able to see, but the taskbar is sort of in the way, where the moraine is. It's pushing the river north, and then it's sort of trapped here by the Talcott basalt ridge this way. So the river is flowing north until it finds a pre-existing notch here through the Talcott Notch, which sort of acts, we know because Amberly Nicolin wrote a master's thesis at UConn about this river about 7 years ago. This acts as a nick point, and it controls the upriver, so back this direction, down cutting of the river. So it's sort of stuck. This position in the basalt ridge here where it flows through has caused the river to be stuck upstream. So it's no longer cutting into sediments. And it's been constrained, we think, for quite a long time. And this site goes on to prove, or in some ways verify, what Amberly Nicolin wrote about in her master's thesis, that the Farmington River is really drained north of this notch, probably shortly after Glacial Lake Farmington, which filled this sort of river valley here, post-glaciation releases about 16,000 years ago. So a little bit about the site formation. Here we can see a digital elevation model. The site is here itself. This is the road going this way. And you can see this ridge snaking to the north. That's the levee that I've been talking about, that terrace that preserves along the edge of the river. The river's ability to transport rock is limited to the river channel in this area here, above the notch, as I was saying. Water from flood events contains sediment. So sediment is burying up and over this levee, and you can see the LiDAR here. This is the ridge going this direction, and there it is again. But rocks and gravel, the river can't mobilize those large cobbles or gravel out of the channel. It's stuck here in the middle. What this does for us, why we care about it archaeologically, is that it creates a lake effect or a drape of very fine-grained sediment over the site and onto the backside of the levee here. So moving this direction as these flood events happened, probably due to spring melt like we see today. During the spring, when the snowpack starts to melt, you get large river systems. It could also be ice rocks and dams sort of throughout this river causing stuff to back up and flood too. That was probably happening quite a bit. And so this was our hypothesis once we discovered the site, but we sought out to test this with UConn Geosciences and Will We Met, who's pictured here with some of his grad students and undergrads, through a series of soil cores. Here you can see we used a vibrocoring setup. So we're using a gas generator with a concrete mixing head that vibrates an aluminum shaft to vacuum remove sediments from these profiles here. That's, you know, a complicated way of describing it, but we can watch it here too. As we're pushing down, that's me jumping on top of it here, trying to move it down. This is vibrating the shaft quite a bit. We're sort of stuck here. We're not moving very much. At the very top of it, we were able to move quite a bit. We recovered, on average, about 3 meters or so of soil in each core. And so I alluded to at the beginning, a ground penetrating radar profile from the original ground surface here. And here what we see is a composite of the site itself. It's sort of exaggerated. The differences in elevation aren't this much. This is a little bit more dramatic just for this presentation. Here we can see the river is this direction from our GPR profile. The site is here underneath the modern ground surface, and here are the Pleistocene sediments in green. And we have bedrock. We know that this is the actual position of the bedrock from deeper cores that the Connecticut Department of Transportation did in preparation for building the bridge. They had to get quite a bit more information about how deep their the bridge abutments needed to go. The bedrock is over 80 to 90 feet deep here and much shallower on the other side of the river. In any case, you can see here the complicated stratigraphy with the ground penetrating radar machine. And then here we can see that Pleistocene site preserved and that levee diving down. And we also see this in the cores too. So here is one of our first cores closest to the river. We have reworked Pleistocene sediments that are redeposited during the Holocene period, we think. We are planning to radiocarbon date these cores. We have not done that yet. Moving away from the river, we have this darker, silty Holocene sediment that drapes over top of the site, pictured here and here. Within the site, we have this yellow-brown Pleistocene deposits, which we refer to as Alluvial 1. I'll describe the site stratigraphy in a little bit. Below the site, we have these basal deposits that predate the site. Again, this is based off of the geology that Amberly Nicolin did. We plan on dating this as well. We think that it's between 15 and 16,000 years ago, and you can actually start to see the coarser grained sediments here at the bottom from the likely braiding of a river before the channel was established. So as that post-glacial Lake Farmington dam bursts, the river is probably sort of wild, and then the channel becomes established and the levee sort of forces it into its modern position. And what's really interesting is you move away from the site, we have a developing wetland, which we think is likely contemporary with the site occupation based on its depth. Again, this needs to be tested with radiocarbon dating, but you can see these really rich organic sediments here draping over other Pleistocene sediments. And so some of the really interesting things that are happening in southern and northern New England during this time period is that we have a really dynamic climate system. There's dramatic differences between northern New England and the Maritimes region and southern New England with different tree sort of biomes. So as you move from north to south, this is an incredibly variable system. It varies through time, as you can see on this graph here. Time is on the x-axis this direction with different amounts of sedges, spruce, and pine pollen throughout time, but also with latitude. So north and south, it varies a lot, as it does today. The climate is quite different, not quite different, but somewhat different in northern New England versus southern New England today. And so there are some ongoing questions about animal community structure in New England, particularly southern New England. It's quite well established that during the time period for early to middle Paleoindian periods, there were large herds of caribou in northern New England. That's less clear in southern New England. They probably are caribou here, but maybe not as many because the forest community is quite different. So the Brian Jones site, and particularly these soil cores that we have preserved, might provide some data points for these questions through pollen and phytolith analyses that we have planned. One of the things that I think is important to discuss when we discuss the excavation of this site is that I sort of alluded to at the beginning, we discovered it in January of 2019. And even though the climate is somewhat different from northern New England, it's still cold in Connecticut in January. So we had a lot of things that we had to deal with through excavating this site in the winter because the bridge was scheduled for construction to begin in April. And so this was logistically challenging. We did most of the excavation in tents that you can see set up here in this aerial view with a drone with propane heaters so that the ground never froze. We used concrete blankets, concrete curing blankets to cover the site each night and heated it during the day with propane heaters. So our excavation strategy, here's a GoPro that Brian Jones set up while we were doing excavation, and he's set it to take a picture every 30 seconds. We excavated 83 shovel test pits, first at 5-meter intervals. You can see the small squares here, and then later at 2.5-meter intervals. And then finally, we excavated 210 1-by-1-meter excavation units. In the STP survey, we discovered 224 artifacts. There was a couple pieces of charcoal, but no discrete features, and only one tool, a piece, escape, or wedge used for wood or bone splitting. In the 210 1-by-1-meter excavation units, over 15,000 artifacts. So quite a bit more. And also, as I said, no cultural features were discovered in the STPs, and we discovered over 27 cultural features or remnants of past behavior, such as hearths and posts, through this excavation, through the meters. And this feature preservation really demonstrates that low energy drape effect that I was talking about with the levee. These features would not have preserved without that sort of low energy environment. So this is a composite section, stratigraphic section of the site. We see 5 soil layers here. The Holocene alluvium is here on top. Again, alluvium means river deposited soils. And then from top to bottom, we have ALV 0, 1, 2, 3, and 4. Cut off with the taskbar, I apologize for that. You can see this is the crest of the levee in the northern part of the site. So this is that Holocene alluvium. And then we've got those Pleistocene sediments moving down. And this is what the actual profile looked like when we drew it. The occupation, the artifacts were found in ALV 0, 1, and 2. As much as we looked in ALV 3 and 4 deeper, we did not find any artifacts. So it seems like ALV 2 is the basal occupation at this site anyway. The first or the second feature that we discovered through this excavation was feature 2, a pretty dramatic, large, sort of a bit amorphous hearth here that you can see with a lot of charcoal preserved here. We collected a charred pine wood fragment that was identified by Lucas Proctor at the University of Connecticut here under scanning electron microscope photography, that you can see apparently to him, these vacuoles mean that it's pine. We sent this for a rapid radiocarbon date while in the field. So this is only week 2 in January. Within 3 weeks, we had a radiocarbon date of 10,520 plus or minus 30 uncalibrated years before present. When you calibrate this with intercal 20, which is the new updated calibration curve that was just published in the Journal of Radiocarbon about a month ago, this calibrates under a 95% confidence interval to 12,665 to 12,475 years before present. You know, that makes it about 12,547 years if you use the median. All of this means that this is the oldest well-dated site in southern New England. And that's pretty astonishing to be in week 3 in the field and know that. It's the only site that I know of where that was possible. The cultural features, there were 44 soil anomalies that were discovered during the excavation. And as I said earlier, 27 of these are cultural features. The non-cultural anomalies included burrows. This is, you know, I like to imagine sort of the Bugs Bunny cartoonish burrow like this. It was pretty big, about 15 centimeters wide or in diameter. There were tap roots that you can see here. And other sort of more amorphous bioturbations. But these were clear that they were bioturbations when compared with some of the cultural features. And as you might imagine, some of these larger hearths also displayed bioturbation too. That's often the case, that these crotavina or bioturbations are found within cultural features because the soil is softer and there is food present in some of these features for rodents to go after. But all of the features were exposed in plan view. They were mapped, bisected, and then profiled. And then when possible, we also cut these in another profile to get them in 3 dimensions. But all of our feature soil throughout this excavation and all of the excavations that we do at AHS were recovered for 100% soil flotation. And that means that we're able to identify any charred botanical remains or microscopic or very tiny lithic flakes or debitage throughout this process too. And again, the taphonomic disturbances, as you can see here to the upper photographs, were clear when compared with intact cultural features, such as feature 9, which you can see here, which is this very vibrant hearth that is partially exposed here. And as I said, where possible, we were able to cut these with a second bisect to see the shape in 3 dimensions to try to really understand the taphonomy or the way that the feature was buried. So if you remember that stratigraphic section that I was talking about, we'll talk first about features in Alluvial 1. There are 19 cultural features preserved from Alluvial 1. All of these were in the southern part of the site here. One of these is a very large cobble feature with 8 discrete sort of sub-features or charcoal stains. So here are the cobbles. Some of them look as if they've been heated. Others are sort of arranged in sort of distinct patterns too. This is feature 6 with these sub-features or charcoal stains that you can see here as I move the cursor in different directions. That's some bioturbation there. Again, I want you to think back that unlike most sites in New England, we have the benefit here of knowing that the river could not transport these cobbles up and out of the channel and into the site itself. That doesn't mean that they couldn't have been transported by some first order or second order stream into the site and then into the river. That is certainly possible, but we found no stratigraphic or stream or river channel throughout the excavations. Instead, what seems clear is that these are brought in by people, probably just right from the river, for some types of activities that I'll talk a little bit about now. But it's really only fine-grained sediments from that lake effect or drape that are burying the site. And you can see here at the base that Holocene alluvium creeping up. So the edge of the levee is sort of right here at this level. This was found 10 centimeters below the stripped soil surface. And there is a central hearth, feature 6C here. You can see this nice gradual sort of shallow profile with a heated rock behind it. This is plan view, that's the profile. We have a post here, feature 6H. Note the diagonal direction of the post itself. We have a few of those. And that's likely because, and these rocks that are in there too, probably helping keep the post in position. And that's because, again, these are sort of different sediments than what you generally find in New England. There aren't a lot of rocks. Generally, in sort of just glacial upland soils, you can dig straight down for your posts, and there's going to be rocks or more hard-packed sediments that will help the post stay upright. But that's not the case here. It seems like diagonal posts were important for architecture. Another post here, dramatically diagonal, 6E. There it is in plan view. And then 6F, sort of a little bit smaller, doesn't go nearly as deep. It's got a little trail here, maybe slightly diagonal, but that could also be a little bit of bioturbation. And then, as I said, that burrow feature here, you know, rodents don't make charcoal, so there was a lot of dense charcoal in this, but it's clearly been bioturbated. So it's hard to know what this was. Based on the placement of posts around it, it could have been a hearth, but we're still in the process of analyzing the sediments and the botanicals from it. We collected throughout the excavations, not only here, but because we know that these cobbles are not naturally occurring, we collected all of them, over 1,800. We recorded them spatially on our unit paperwork, and we also took soil samples from underneath most of them for possible later analyses of phytolith or pollen analyses too. So as I've said a couple of times now, these cobbles were not deposited by the river. So here we can see the picture and then a drawing of them. This brings to mind a couple of ideas. Namely, one is the Tennant Swamp site, another Paleoindian site in Keene, New Hampshire, where they found feature 2, this cobble feature, that was interpreted as possibly discarded boiling stones from the hearth. So using probably animal skins to cook different things, using boiling stones to heat up and then add to it. That's an interesting idea. That's possibly what we have. Again, I said some of these are likely heated. There is a little bit of fire-cracked rock within this cobble feature as well. It could be that it's also, if you go back, a temporary oval structure, a large sort of oval structure like at Tennant Swamp. So this is in the plan view and then here with the drawing. But it could also be that we have two lean-to structures here. 6E and 6F were two of those posts that were diagonal in the same direction, and 6H as well. Sorry, 6H and 6F, which I think is really important. Again, this burrow feature is here in the middle, so it's hard to know what that is. Same thing here with a central hearth with this feature. In any case, there were 2,000 artifacts in the top 20 centimeters in this area. A local hornfels dominates, and numerous formal tools, including 15 end scrapers, 14 side scrapers, 9 piece escas, 3 spoke shaves, a denticulate, only 1 projectile point fragment, and 30 utilized flakes. Most of the reduction seems to be unifacial resharpening, some biface production. There are a couple of channel flakes, but nothing like we have in the northern part of the site. And some of the reduction is bipolar, but that's likely from simply using the wedges and then turning them around in a different direction to use them again. So one working hypothesis that we have for this area is that it's not temporary houses, but it's probably an animal hide processing area with posts and fire pits. And what we're seeing is the processing of hides for tent material or clothing. It could also be overprinting, of course. It's unclear until we get a systematic suite of radiocarbon data of all these features, how long this surface was stable. All of this is occupied in one event, or it could be several events too. When you compare the cobble map here from that top 10 centimeters with the artifact distribution, it's pretty interesting. The artifacts are situated near or adjacent to the cobbles, but not on top of, which suggests, I think, that that they're contemporary, that they're using the cobbles in a different way than they're using the lithic material. So here you can see that distribution map of all lithics in the southern part of the site, a little bit brighter. And here we can see a distribution map, not the plan drawing, but distribution of the cobbles. And when we compare them again, you can see that the cobbles in green are adjacent to, but not in the same area as the lithic artifacts, which is, I think, quite striking. Again, boiling stones are possibly used in animal hide processing. There is also a second occupational level deeper at 30 centimeters in Alluvial 1. We know this because there is a large hearth feature, which you can see here, preserved 30 centimeters below the strip soil surface, over here to the lower left of this plan. This is feature 22, as I said, a small hearth. There is a clear, discrete napping area around this. You can see again from those distribution maps on sort of all sides of the hearth, but not on top of. And here is some of these artifacts that were pedestaled as we were excavating them and recording their locations. What's also incredibly interesting is that we have this possibly drilled pendant here you can see under a microscope and from farther away, made out of hornfels. You can see the circular patterns here for this artifact and a possible groove here found discarded with the other debitage. So incredibly interesting. Ornamentation is incredibly rare at most archaeological sites, and even more so during the Paleoindian period. This remains to be looked at by a use-ware specialist. We're in the process of doing that, but it is incredibly interesting. What's also, I think, very interesting is if you look at that area in the site, again, here's that Holocene, the levee is here, this is the Holocene sediment. That hearth is resolvable in the ground penetrating radar. So we can actually see that circular hearth here in the plan view of the radar. So if we move to the northern part of the site, but go down one stratigraphic level to Alluvial 2, so lying below Alluvial 1, we have 8 discrete features. So while there are artifacts in Alluvial 1 here to the north, we have no features in Alluvial 1 in this area. So it's only Alluvial 2 features that are preserved, but we do have artifacts preserved in a stratigraphic layer above this alluvial 2 layer. 8 of these features are present. 5 of them are hearths, which you can see here. As I said, it's the northern portion of the site. This area is dominated by biface production. We know this from discarded or broken stage 4 or nearly finished bifaces, but also numerous channel flakes are found throughout this part of the site too. As we look through some of these hearths here, this is feature 2, the hearth that was radiocarbon data that I spoke about earlier. Again, it's clearly a hearth based on the charcoal, but we also have pot-lidded or artifacts that were in the hearth or the heated soils that the pot lid fractures in an unpredictable way. And this is a sort of telltale pot lid scar indicating that this artifact here, this piece of Norman steel chert, was heated to a high temperature from this hearth. And this is looking at this sort of ephemeral, sort of shallow basin shape of the feature itself through the profile. Feature 9, shown here, somewhat larger than feature 2. This is a close-up of when we initially discovered it here, with some probable bioturbation moving at this direction or this direction, as you can see here. Here we see feature 11. Again, a lot of it's cut off here. And there's a profile here. You'll have to take my word for it because the taskbar is in the way, but it shows again a sort of shallow depression here for where the charcoal is, and this is where it is in the site. Feature 20 is here. You can see it here with this very large, the largest inscraper that we have. So certainly not at the end of its use life, but simply discarded or forgotten about here at the edge of the fire. Feature 28 here, a pretty large, again, sort of amorphous probable hearth. What's interesting about feature 28, there's a lot of napping sort of around it, but what's really interesting is this small feature next to it, feature 29, which has this red ochre or red pigment staining here, which you can see, or it's hard to see with the yellow circled here. So just adjacent possible pigment processing area. And here I've done a de-stretch transformation, which simply highlights the red pigment that is difficult to see with the naked eye. These nodules, we have over 30 discrete nodules of ochre here, and you can see a picture of 3 of them. And we also have a quartz flake with ochre preserved on it as well. This is actually from a northern part of the site, not here where this ochre was, so suggesting possibly ochre use maybe in 2 different time periods, or at least 2 different spatially separated areas. So what about the artifact distributions in Alluvial 2 in the northern part of the site? Like Alluvial 1, and as we might expect based on numerous other Paleoindian studies where features weren't preserved, but people have interpreted the location of features based on artifact patterns, we find that the artifact patterns mirror but are slightly adjacent to many of these features here. So again, you can see not a lot of artifacts here next to this feature. That probably means there wasn't intensive tool production, maybe just a little bit of tool use and discard here. But a lot of these do have intense biface production or tool use adjacent to these features. Nearly all of the artifacts from Alluvial 2 are made from Norman steel chert from the Hudson River Valley. And here's a better image of those distribution patterns here. So we have some preliminary plant identifications that were done by, identified by Katie Reinhardt. You can see here a whole suite of different charred plant material has been found at several of the features. Feature 2, the one with the radiocarbon date, we know that we have cattail, pin cherry, and water lily, looking like probably a summer occupation. Cattail is available sort of all year, but it's better in the summer too. And then at feature 9, we have cattail, strawberry, water lily, sumac, pin cherry, and oak as well, so acorns. And again, sort of beginning to fall within that sort of same summer occupation at these two features that are adjacent to each other but not overlapping, which is suggestive, I think, of contemporary possible occupations. What's also really interesting, if you remember back to the vibrocores that I showed you, we have several wetland species, tubers and annuals, that are preserved at the site, suggesting again that the wetland was a possible draw for people to this location too. You know, these seasonality estimates are based on modern extant flora and when they flower. Today, it's possible that during the Younger Dryas, seasonality was quite different than today. So, you know, that's the best that we can do, is base it off the modern extant flora and fauna. But it is possible that during the Younger Dryas, during this sort of post-glacial Pleistocene environment, seasonalities were quite different. We also have a very large grinding stone with a clear grinding surface here from ALV2 near features 28 and 29. We have not done the or phytolith analyses that we have planned for this artifact yet, but we are going to do it. So it's entirely possible that this was used to process plant material or possibly ochre material too. As far as calcined bone, we do not have a lot of it. Only one specimen looks identifiable at this point. Here you can see this is out of a small artifact box, so it's quite small. Small game, probably reptile, probably a turtle, still in the process of identifying it. But again, if you look at least these two features, feature 2 and 9, and also the way that those features were spatially segregated, it is entirely possible that we have a contemporary summer encampment in Alluvial 2. So onto the artifacts now and the different types of raw material, of lithic material that we have at the site. We have, as I mentioned, quite a bit of Norman Skill chert you can see here from the Hudson River Valley. We have Hardy and Jasper from the Delaware River Valley or Pennsylvania and New Jersey. We also have some chalcedony that looks like it's probably coming out of the pillow basalts that are sort of adjacent to the site, the Talcott Basalt Ridge, or at least from the West Rock chalcedony area, just one sort of drainage over in Connecticut, although this is the same sort of rock formation adjacent to us, so it probably has the same chalcedony too. Hornfells, most likely from Suffield in north central Connecticut. Here you can see with this piece ESK made of that hornfells. We also have some banded rhyolites. Some of them are more weathered than others, probably from northern New Hampshire, but I wouldn't rule out Boston Basin as possibilities. They're spherulitic and banded, so that fits within the Jefferson and Mount Jasper rhyolite classifications, but there are also banded spherulitic rhyolites from Massachusetts as well. Some hints of possible Munsungan chert, red chert with blue veins like you can see here. From Maine, not a lot of it though. If we do have it, it's in very small amounts, which would sort of make sense for this far south. We also have the red chert or Kingston chert or Indian River chert variety from the Hudson River Valley here, which is red like Munsungan, but it has sort of these black inclusions which give it away as the Hudson Valley. And then we also have some local cobbles. So alluvially weathered small packages of chert that you can see here. Some of it has jasper inclusions within it as well. Unclear where these are coming from, but we think based on the small package size and how it's weathered, it's probably coming out of the river itself. And then a fair amount of quartz, although this is in, I haven't talked about it yet, it's in the ALV0 occupation above ALV1, which I'll get to in just a few minutes here. So if we look at the distributions of these artifacts, Norman Skill chert dominates the assemblage, and that is drawn here to the northernmost portion of the site, where we had numerous biface production and channel flakes here, as well as in this area, we have a lot of biface production too. Over 8,000 artifacts made from Norman skill. Hardest in jasper, much smaller amount, around 650 or so here in this portion of the site. Trap rock chalcedony, located to the southern part, mostly in Alluvial 1, and then here to the northern part in Alluvial 2. Hornfells, that local hornfells is only found for the most part in the southern part of the site. Quite a bit of it, 1,500 artifacts. I should have mentioned nearly 2,000 artifacts made from chalcedony. And then rhyolite, again, New Hampshire, possibly Massachusetts, in this portion of the site, the northwestern part of the site. What's really interesting about these is that the raw material packages, like the spatial segregation that we see with the hearths, is highly localized within the site and by stratigraphic units too. So we're seeing different occupations in ALV1, ALV2, and as I'll discuss in a minute, ALV0, at different hearths with different types of raw material, suggesting, I think, something about migratory behavior of Paleoindian peoples, where they were coming from, where they were possibly meeting up at the site as an area, as a sort of stopover area, but as maybe a large aggregate area like we see people have talked about with Bullbrook as well. I mentioned the quartz component in ALV0 above ALV1. It's entirely possible, and in fact probable, that this is an early archaic component. The quartz was located 50 centimeters above ALV0, ALV1 in ALV0 here. Nearly all of the material from this upper layer, again, we have artifacts in HALV, but that's the middle woodland site, sort of in the top 40 to 60 or 70 centimeters here. And then ALV0, likely early archaic, nearly all of it's quartz. There are some larger artifacts though made out of quartzite, like this chopper here. But we do have at least one Gulf of Maine archaic microcore that you can see here and here. That's actually Brian Jones holding it up for a picture. We also have some different quartz technology. So a centripetal or prepared, or in Europe they call it the Levallois core. So a different type of lithic reduction going on there as well at the same level. Again, not necessarily the centripetal core, but these microcores are indicative of a Gulf of Maine archaic occupation. Unfortunately, we don't have any discrete features in this layer, but we do have charcoal in the sediment, and we're hopeful not only through the charcoal we recovered through the excavations, but also through the vibrocoring effort, that we'll be able to well date the stratigraphic layer ALV0 as well. And then here, if we look at that quartz distribution, nearly 1,500 artifacts, again, spatially segregated here in the northern part of the site, but also stratigraphically, most of it is in ALV0. Some of it is in ALV1. So if we look at some of the tools found at the site, we have piece escas. Here are the top three, are these wedges here. One of them is made on cobble chert, this one here. We have some gravers down here to the bottom right. We also have spoke shaves, so for woodworking here. Many inscrapers made from different materials. We have quartz, possible Munsungan chert here, although probably this is heated jasper, that banded rhyolite, chalcedony, more of that cobble chert. This is rhyolite, but it could be that this is not an inscraper, that it's probably a broken sort of drill or owl fragment. Numerous large sort of side scrapers, although some of them are this, we have this also multi-purpose sort of side scraper, but also with a graver portion of the tool as well here. I mentioned before that we have several channel flakes. Many of these actually refit into a larger channel flake. This on the right is not a channel flake, it's a larger sort of end thinning flake from earlier in the biface production, but again, clear bifacial production and fluting happening at the site. Utilized flakes, these are all made from that banded rhyolite, but we have them from all of our types of raw material. As I said before, stage 4 bifaces. Here's a broken one, just the tip from that rhyolite that's weathered. More of that rhyolite here. We actually have, it's not shown here, but we have a side flake removal that refits onto both of these. That actually is where they broke that. This is Norman Skilled Chert, and this is that Indian River or Kingston, Hudson Valley Chert. And then our point fragments. So here we have the fluted point base, the only fluted point that we recovered. We don't have all of it, we just have the tip here, or sorry, the base. It looks most like a Bullbrook or West Athens Hill form. There's both slightly different, but fitting within that early period, like our date. This is from Alluvial 2 as well. And then we have some possible tip or point ear fragments, depending on how you orient them, to the right and to the left. We have a few overshot, so flakes that are coming up and over a biface, but this is really an insignificant part of the assemblage. It's not, we don't think that they're doing a lot of controlled overshot flaking at this site. It's probably something that's just sort of routinely happening through biface production, maybe on accident. It's not something that they're targeting through their reduction. So what does this mean? Well, overall, I would say that it's a very typical Paleoindian toolkit. And based on the spatialized activities in the different stratigraphic layers, we have many specialized activities preserved at the site in different time periods too, which is, again, something that people have come to expect from these Paleoindian sites, that they're highly spatially organized campsites where different activities are happening sort of throughout the site. And that's exactly what we have at the Brian Jones site. But we also have some of these non-typical artifacts. Groundstone technology is not common or generally found at Paleoindian sites, and yet we have it buried over 2 meters below the original ground surface with Paleoindian artifacts. So it's hard to discount it as being a part of the Paleoindian occupation. We have evidence for ornamentation through the possible pendant, also through the presence of the pigment as well. Although some people have suggested that pigment, particularly red or particularly ochre, has adhesive qualities, so it might not be ornamentation, but sort of either or. Some of the other things that we did throughout the excavation is we make sure we do detailed photography so we can reconstruct our excavations in 3 dimensions, as you can see here, of our plan view of the excavations around feature 2. And then, so sort of wrapping up, this is an artistic reconstruction of the site by Julie Luhman. What do we think? You know, we're still in what I would say is the preliminary stages of analyzing this site and all the information that we can glean from it. But what do we know so far? We know that the site is located along the Farmington River. We know that rivers throughout, you know, prehistory, pre-colonial periods, and into historic periods as well, are major transportation routes for people through all time periods. And that's no different here in New England, particularly in this area. So the Farmington River, if you follow it upstream, which is, again, slightly south for a little bit, but then north, that gets you sort of a couple of drainages away from that Hudson Valley Chert. If you follow it south, then you're into the Connecticut River. And then from the Connecticut River, you can go north and south throughout all of New England. What about animals? Caribou. We're exploring the processing activities through use wear and residue analyses that we will complete on the tools. It's highly likely that they were processing hides. Are those caribou, or do we start to see some more temperate fauna in southern New England move in? Let's wait and see. small game as well. Certainly a reptile preserved in the calcined bone assemblage. Possible fishing or netting along the river. Again, we have no evidence for that, but the river is there and there are fish that are running throughout the year. It's also directly upstream of a tributary system, so a good area for fresh water. There is that developing wetland right behind the site, and we have clear evidence for wetland acquisition of plants at the site. It's also just a good place to camp. It's not going to be wet. They're well-drained soils on a high crest of a levee. So while the site does flood occasionally, certainly it floods because over 1.5 meters of sediment build up above the highest part of the Paleoindian occupation. It's pretty dry when it's not flooding. It's also sort of a good stopover point between these raw material areas. So again, during this remote period, over 12,000 years ago, the ocean is farther offshore. It's, you can sort of get to Pennsylvania more directly than you can now, sort of through the Long Island Sound area. But it's also sort of in between the New York sources, possible New Hampshire and Maine or Massachusetts sources as well. So it's sort of in the middle. Again, I think suggestive of one of these possible aggregate or meetup spots. It's not something that I had time to talk about today, but I think one of the more important contributions of this site to Paleoindian studies in New England is that there are now 2 deeply buried Paleoindian sites adjacent to rivers in Connecticut, with the Templeton site in northwestern Connecticut. And that is incredibly important for finding other Paleoindian sites. It's not that other archaeologists have suggested that Paleoindians didn't spend time next to rivers. Of course, most, if not all, archaeologists believe that. It's that geomorphologists and archaeologists have thought for a long time, for good reason, that these rivers weren't stable 12,000, 11,000, 10,000 years ago due to glacial outwash. And that's simply not true, at least in Connecticut. We now have 2 sites where preservation was possible and indeed did happen adjacent to these rivers. And the rivers in Connecticut are no different from the rivers throughout New England. So these 2 sites now show sort of a roadmap for where some of these other deeply buried sites may be, if you can find mechanisms for the preservation, like at Templeton and here with the Nick Point at the Brian Jones site. We have lots and lots of research that is ongoing with this site. We're still continuing to conduct the lithic and botanical analyses. We have a suite of radiocarbon dates planned for the cultural features, also for the vibrocore studies. I alluded to residue and microscopic use-wear analyses that hopefully will tell us a whole host of things about the types of animals or plants they were processing. We're going to try to do raw material sourcing for those raw materials. Again, we're pretty sure of some of those raw material sources, but it never hurts to look. Pollen, phytolith, starch grain analyses. We want to really narrow in on the taphonomic preservation of the site through micromorphological or minute study of the way the site was buried. And with that, we're going to do a whole host of geochemical analyses of the soil cores as well, that is sort of beginning to get started. We're also thinking about stone tool refitting to try and look at if these occupations were contemporary or not. Some of that we've had a bit of success with already, as you can see here, with this unifacial resharpening flake on this end scraper. Of course, these were only about 1 meter apart, so they're not really helping us know anything about between those spatial occupations yet. But we have a lot more to do with this site. And there are many, many people to thank through the excavation of the site, not least of all, Brian Jones, who, again, the site is named after because of his prediction, really, that something could be there, but also through his helping out while he was battling cancer and the Office of State Archaeology. He provided some of the tents here that we can see. The Connecticut Department of Transportation, which funded all of this research, because of the construction of the bridge, but really never batted an eye at funding it. Yukon Geosciences, who's collaborating with us on most of the geologic work, the Connecticut State Historic Preservation Office, who also supported this effort, as well as Rotha Construction, the construction managers who built the bridge, who were really phenomenal to work with and helped sort of avoid the site as we were excavating it, and the town of Avon. So I think that's it for me. If I can figure out, I'll take any questions now.
Well, thank you, Brian. So we've had a few questions come in. So one is, have you considered using optically simulated luminescence dating for inorganic features to complement the carbon-14 dating of organic remains? This approach can work well, but not always.
Yeah, so I do know about OSL dating. I haven't really considered it here because unlike most other sites in the Northeast, we're fortunate to have 27 cultural features, as well as numerous charcoal flecks throughout the alluvially buried sediments. So OSL is a good dating method when others aren't there, I think. But oftentimes the standard of error for OSL is sometimes outside of the human occupation windows that we're looking for. And carbon-14 dating, when you can date annuals or even charred wood, provides a much tighter interval. So while I'm familiar with it and I would consider it at many different sites, I'm not considering it here because we have so much charcoal and because we have so many features that are preserved.
Okay, thank you. And everyone, don't forget to use the chat function down at the bottom if you have a question. We have another one. It's about the ochre. So what does ochre being present suggest? And what time period would it suggest? And what would the source be for the ochre?
Yeah, so what a good question. I'm not sure what it suggests. I think that it suggests that people were using a red pigment for something. I don't know what yet. We see it preserved on at least one flake. So probably they were prepping it with that flake or using it for something. As I said, some archaeologists working in South Africa on the earliest sort of hafted or composite technology for weapons or spears or arrows have suggested that ochre has sort of adhesive qualities like a glue. So like a tree glue that they're using to bind the point to the spear itself. That's possible. It's also possible that it's something that is used for painting clothes, painting, adorning bodies too, painting skins that you're using for your tents, a whole host of different things it could be used for. It doesn't really signify a time period. It's found in the alluvial 2 layer, which is the only layer that's dated right now. So it's that earliest occupation at around 12,500 calibrated years. But pigment is used sort of throughout human history. There's early pigment use over 200,000 years ago. So doesn't really signify a time period so much as it's something that preserved. It's probably used at lots of sites, but it doesn't preserve. As far as sourcing it goes, that is incredibly difficult. And as I understand it, nobody has undertaken a geochemical sourcing of ochre in New England. And that's most likely because in New England, we have, at least in southern New England, we have incredibly iron-rich soils. And so ochre actually precipitates throughout southern New England in different varying degrees of nodules. And it actually precipitates through heat too. So you oftentimes can get these sort of red soils from hearths themselves. So people potentially could have created ochre simply through their hearths as well. So it's a very difficult thing to study how it's sourced, I think.
Okay, thank you. We have another question. Were any of the Connecticut tribes consulted and involved in the research fieldwork on the site? And I'll add to that, or what is their involvement today with it?
Yes, so It was a federally funded project. The two federally recognized tribes in Connecticut were both consulted on the memorandum of agreement that was associated with this project, the Mashantucket Pequot and the Mohegan. They visited the site. Their involvement today is as one of the tribes is a signatory of the memorandum of agreement. So they are continuing to be involved in the consultation process.
Excellent. We have another question that just came in. You mentioned lean-tos. What guesses do you have about the nature of those structures? How do you know they were lean-tos, maybe?
Oh, I don't know that they're lean-tos. I have no idea what types of structures those were. And I'm sorry if it suggested that that's what I thought. I think that they could be lean-tos. So a couple of poles together for a temporary sort of tent that's sort of more, so it's quicker. I also think it's entirely plausible that those lean-tos aren't for habitation, but they're for drying animal skins and smoking them. So I think that it's more likely based on the tools that we have there, particularly the side and end scrapers, that what was happening in Alluvial 1 at the southern part of the site is a massive hide preparation and tanning process where they're using posts to simply dry them over top of these hearths as a way to prepare for winter, for making clothing or tent material. Or possibly, it's something that you see sort of in the spring. Other archaeologists have suggested that you can tell the difference by the residue in the use wear, if it's a fresh hide or a sort of old hide and what they're preparing. So again, we haven't done the use wear analyses yet, but I'm hopeful that the polish on some of these chert artifacts will tell us if they were fresh or new hides they were preparing.
Okay, we have one last question. Have you done any test pits outside of the area affected by the bridge? And if you have or haven't, would you expect to find a larger site or another site, maybe?
Yeah, so it's a good question. We tested outside of, so if you look here, you know, this is a federally funded project. So we were limited to the project area that was going to be disturbed for a number of reasons, but mostly because, you know, we're using taxpayer money to target this area to see if there's cultural material. So we did not test in general outside of the project area. We tested where they were going to deeply disturb it. And before that, it was tested in the surficial or sort of 1.5 meter soils as you move back from the bridge where they, where the road is, but there's not deep disturbance. I see no reason why other portions of the site might not be preserved outside of our project area. In fact, I think it's highly likely that outside of the project area, portions of the site are preserved. And I think that Amberly Nicolin's master's thesis, which shows the control that the Nick Point has over the Farmington River and the creation of that levee along the Farmington River, suggests that if there were people during the Paleoindian period along the riverbank here in the Farmington River Valley, their occupations would be preserved elsewhere too. There are, I think, reasons why this area was occupied because of that stream sort of here and the wetland, but certainly I don't think that all of the site was excavated in this project. I think that all of the site within the project area was excavated in this project, if that makes sense.
Yeah, no. Thank you. That's what we're going to do for questions tonight. I just want to let everyone know that, again, next month, the third Tuesday, we will be hosting Greg Lott again talking about Norse and most likely iron making and everything. Again, thank you, Dr. Leslie, for talking with us tonight and sharing this with us. I think this was really interesting. I know I learned a lot. Vic, do you have anything else before we let our membership go?
I just wanted to express my great appreciation for Dr. Leslie giving this presentation. It really was one of the better ones I've heard in a long time. Very concise and really full of, jam-packed full of information that's really exciting.
So, okay, well, thank you guys. We hope we see you next month. And have a good night.
Okay, thanks for having me.
Thank you.
Thank you.
Bye.